This video we're going to discuss how to integrate using the integration by parts. By using integration by parts, so we need to memorize the formula uv minus the integral of v du. So since our given problem is the integral of x sine x dx, so since the problem having two function, which is the f of x and the g of x, if f of x is equal to x and the g of x is equal to sine x, then we can simply use the integration by parts, and we let x to u, let x to u and the sine x to v, and find the derivative, and the derivative of u is du and the derivative of x is dx, the derivative of v is dv, and the derivative of sine x is cosine x. So as I said in this previous slides, the formula of the formula that we use, if we use the integration by parts, so we need to memorize the formula u v minus the integral of v du. So since our u is x and our v is sine x, minus the integral of the v, which is the sine x, and the du, which is dx. Since we only have one functions in our integral, which is the integral of sine x dx, so we can simply answer this by looking up the formula of the integral of trigonometry, which is found in my last video. I wrote some of the formulas of integrals in solving trigonometry. So the integral of sine x, which is the integral of sine x dx, is negative cosine x, which is the opposite solution of the derivative of cosine x, which is negative sine x. So since our sign that we use in the formula is negative, so the derivative of the sine x, which is negative cosine x, multiplied by negative is positive. So we got x sine x plus cosine x plus c. For our next example, we have x squared e to the power of x dx out. The integral of x squared e to the power of x dx. So since our problem has two functions, which is the x squared can be lit as u and the e to the power of x can be lit as v, and the derivative of u is 2x dx, and the derivative of v, which is e to the power of x, is e to the power of x dx. So the derivative of e to the power of x is always ax. Therefore, the integral of e to the power of x is also e to the power of x. So by using the formula of integration by parts, so the u v minus the integral of v du, so our u is x squared and our v is e to the power of x, subtracted to our v, which is e to the power of x, and our du, which is 2x dx, which is 2x dx. We can simply out any numbers or any whole numbers to the integral. So we can simply out. So that's how 2 is out of the integral. 2x dx. Since our answer has it has two function, which is the x and the e to the power of x, we can use again the formula of finding the integral using the integration by parts. So we can let again x to u. So we can let again. So we can let again x to u and e to the power of x as v. So the derivative of x is just dx, and the derivative of e to the power of x is e to the power of x dx. So since we have now the value of u, v, and the du, so we can solve the problem. First, copy your first answer, which is the x squared a to the power of x subtracted to 2 enclosed to the quantity of subtracted to 2 the quantity of x a to the power of x, which is our u is x and our v is ex, subtracted to the integral of v, which is e to the power of x, and our du is dx. So since our answer has already one functions inside the integral, so we can simply use the basic integral or the normal integral of this function. So the integral of ax, as I said, is also ax. So we have x to the power of 2 a to the power of x minus 2x a to the power of x plus 2x to the a to the power of x plus c.